Hello. Welcome to your final session here at PDC 2008. Hopefully it's been a good week and you are packed full of all kinds of interesting new technical information to take home and apply. My name is Rich Randall. I'm the development lead for CardSpace Geneva. And as somebody dubbed me as I walked in here, I'm your final geek for the week. So today we're going to talk about one of the components in the suite of software and services that Microsoft has introduced over the past week for making application writers' lives easier with respect to identity. And in particular, of course, we're going to be focusing in on Windows CardSpace Geneva. So today we're going to start with a small overview, vocabulary review for those of you that didn't make it to some of the other talks on claims-based access control. We're going to delve right into what's new in CardSpace Geneva. There was a previous version of CardSpace. We're going to talk a little bit about what's new. We're going to show you the experience right off the bat. Then we're going to back up a little bit and talk about protocol, architecture, how it works under the hood. Then we're going to talk a little bit about why CardSpace is interesting to an application writer. Why would you use this as opposed to something else? And finally, we'll talk a little bit about where CardSpace is going in the future. So, a little bit of vocabulary review. Claims-based access model. It's based around claims. A claim is simply a statement about a user. Can be anything as simple as shoe size, which is one of our favorites for one reason or another. Could be as exciting as they're an admin, they own a particular role, or some other characteristic of that user. A security token is simply a collection of those claims collected into a document that's generally signed by an issuer and produced by a security token service, also known as an STS, as I'll refer to it throughout the rest of the talk. The identity metasystem is the system of protocols and components that facilitate the exchange of tokens between identity issuers and applications that consume those claims and tokens. And finally, a claims-aware application is one that can consume claims natively, understands how to use claims to offer access and authorization to its users. What is CardSpace? CardSpace is the client of the identity access model. Geneva is composed of a server that issues tokens, a framework that can be used to consume those tokens, and CardSpace Geneva, which is the protocol client that facilitates the user's interaction within this system. It's a protocol client first and foremost. It speaks, or it can interpret WSDL and WS security policy in order to determine where to go collect tokens on the user's behalf. And it participates in WS Trust security exchanges with STSs in order to collect those tokens and return them to appropriate applications on the user's behalf. Secondly, it's a user interface. This is what gets the user involved in the system and puts the user in control of their identity. CardSpace puts a friendly handle on identities for the user, allows them to see what's being done on their behalf, and allows them to make decisions about what identities they want to apply to what applications and at what times. Lastly, CardSpace is a credential collection interface. And in this sense, it makes it simpler for the user to interact with credentials. It gets applications out of the business of collecting credentials for users and facilitates a certain amount of credential agility so that applications don't have to worry about what kind of credential they're going to be collecting today based on business or security needs. So, as I mentioned earlier, CardSpace Geneva is the second version of CardSpace. We did have a V1 version of CardSpace, and we learned a lot from the V1 version of CardSpace. In my V1 days, when I worked on CardSpace V1, I spent a lot of time looking for the following kind of user. I wanted to find the kind of user who was interested in going to eBay, for instance, and logging in because they really wanted to savor the authentication experience. Unfortunately, I'm still looking, and I haven't found that user. CardSpace V1 was, in many ways, optimized for that particular user. So what we learned from V1 was to get out of the way, primarily. Users are interested in getting into applications, getting services, and authentication is one of those steps along the way. And it's not something that they want to wallow in or savor. And as a result, we have drastically reduced the footprint of CardSpace Geneva. And in order to do that, we started all over again. We wrote it from scratch, from the ground up in native code, because while I love managed code, if you have to squeeze every bit of performance and size out of your application, there is just no substitute for native code. And so that's what we've done. We've rewritten it from the ground up to be as small and as fast as possible to get people efficiently and quickly logged into the applications that they're interested in. And with that, what I'm going to do is a very simple demo where we will take a look at what the experience looks like today. I'm going to compare and contrast with the V1 experience. So we're going to start by logging into federatedidentity.net, which is a public website that we've put up that you can use to experiment with CardSpace and the experience. I've got V1 of CardSpace installed on this machine. And so I'm going to go to federatedidentity.net. No, I'm not. I'm going to have to fix my network settings first. Okay, we're going to try that one more time. This time for sure. Getting there. All right. So we're at federatedidentity.net. There's a simple icon that indicates that you can use CardSpace to log in. I click on that icon, and then what happened? Well, we're transported to a whole new world. It's a secure world. Yes, I want to choose a card to send. I want to choose that card. Click send. Yep, let's do that. Any minute now, the slick guy from Apple is going to show up and start making fun of me. What was it that I was doing again? I was trying to log into something, I think. We're getting there. Yes, indeed. This is a particularly effective demo currently, even more effective than I had intended, actually. Okay, so, yep, we're still savoring. Okay, I'm going to give up on savoring. So that is sort of a V1 tour. So now for V2. Let's do CardSpace Geneva. So first I'm going to install it. This is not the RTM install experience, but it's what we've got for beta. It's still relatively fast, quick to install. The download for x86 is under 5 megs currently, so downloading it is very quick. Installing shouldn't take very long at all. We'll be spending even more time on speeding this up before RTM. So we want this to be as quick as possible. So now we're installed. Let's go back and try this again. We're going to go back to federatedidentity.net. We're going to detect some proxy settings first, of course. This was not the part I wanted to savor. Indeed. All right, well, That's too much to savor. Well, that's, here we go. We've made some progress. All right. Okay, now we get to CardSpace. Huzzah! We're authenticating. So here's our current list of cards. There's only one installed currently that I can use at federatedidentity.net. If I want to, I can click this to use this card in the future. I can see what claims are going to be sent. It's only one. It's a PPID claim. I can log in. Ta-da! So, minus the long lag time at the beginning. Considerably smaller, a lot faster, a lot more intuitive, and out of the way, primarily. So that's what we've done. We've spent the majority of our time making CardSpace smaller, faster, and lighter. Yes, although, here, we'll try. We'll get to that. All right. So how does CardSpace work? We're going to delve a little bit into the basics again. So at the center of CardSpace is the information card. An information card serves several purposes. To begin with, it contains the information needed to give the friendly metaphor to the user. There's a picture, a friendly name. The user can use this to select the identity that matters to them in the context of the application that they're trying to access at the time. It also contains information that's primarily consumed by CardSpace itself. There's a token issuer reference that tells CardSpace where to go to get the token on the user's behalf that represents this particular identity. There is a list of issuer capabilities that describe the set of claims that this particular issuer is willing to offer and the formats in which the issuer is going to issue those claims. In addition, there's a reference to credentials in a card. But it's important to note that a card is not a credential. A card contains a reference to credentials. Could be a hint about the username or password that the user can use to log in. It could be a reference to a particular certificate used to authenticate the user to the STS in order to obtain a token with claims in it. It could also be a reference to a smart card of some sort. But the card itself is not a credential. Although in many ways and many times we can use the card to hide the fact that there is a credential in the background because we can strictly associate the card with a particular identity and a particular credential. In the case of things like smart card or Windows authentication, simply selecting the card itself can enable CardSpace to collect the credentials on the user's behalf without having to prompt them a second time for credentials. So the card is central in the protocol flow, which has basically three phases. We start with policy retrieval, where we determine the characteristics of the tokens that the applications and STS need in order to log in. CardSpace then uses that to filter and select a particular identity and a particular identity provider. And finally, CardSpace will track down the right tokens and exchange them for tokens that can be used by the user at the particular application. We'll walk through that for a sec. On this slide, we've got a user at Fabricam. That's his home realm. He's trying to access a application at Contoso. These are two famous companies. First thing that happens, the user's web browser hits the Contoso application. The Contoso application is going to return the policy, the set of requirements that describe the kind of token that the Contoso application needs in order to authenticate that user. It's also going to contain a reference to the STS from which it will accept that said token. CardSpace will take that policy and use it to track down that STS and find the particular endpoint at which it will retrieve policy from that STS in order to determine what requirements that STS has for claims to authenticate the user. At this point, CardSpace has everything it needs to help the user select the right identity to get access to this application. So CardSpace applies the requirements that it retrieved from the last STS to the list of cards that it has within its store, and does a filter and intersection process to determine which of the cards could possibly satisfy this particular STS, and only presents that particular list to the user, which may be somewhat ambiguous, may have several different cards that the user could choose from, but the user can choose the card that most appropriately matches the context of this application and applies the right identity for this particular application. Once they've selected that, CardSpace collects the credentials that the user needs to unlock this particular identity. It takes the policy that it retrieved from the Contoso STS, and it takes the card ID and submits all of that to his own identity server, where his identity resides. That identity server then uses all of that to determine whether it can mint a token for this user for that particular application, sends it back to CardSpace, at which point CardSpace exchanges that token with the Contoso STS for an application-specific token with the claims that are specific to that application, and finally the user has access to their application. At this point, I'd like to show you precisely how you can integrate CardSpace into your application. So in previous talks, you may have seen the talk that Stuart and Caleb gave on the framework and server overview. In that talk, they had a Geneva server to which they basically turned over all authentication and credential collection jobs to that particular server. And that is one way that you can do this. In this talk, since it's a CardSpace specific talk, I'm going to focus in on a particular application type in which the application writer wants to integrate CardSpace more carefully into their application. They want closer control over the experience of logging into their application, and they don't want to outsource that to another party or an IT admin or somebody like that. So what we're going to start with, we're going to go back to our favorite company, Contoso Hybrid here. And here at Contoso, we've already got an application that Contoso employees can access. It uses Windows Integrated Auth. Contoso users log into this site automatically. They don't have to do anything. It's customized with their name, and they get access to the stuff they need. However, we want to federate. Contoso wants to federate with their favorite partner company, Fabricam Motors. But Fabricam motor users can't use this application directly because they don't have an account at Contoso, which is what they need to use Windows Integrated Auth to log in. So how can we make this better for Fabricam users? We'll go back to Contoso, and we're going to go through a few simple steps in order to enable CardSpace integration into the Contoso application. The first thing we're going to do is we're going to turn off Windows Integrated Auth in IIS. We're going to turn on anonymous authentication, which enables the Geneva framework to take over authentication. Then we're going to open up the web config for this particular application. It's a simple ASP.NET application. And we're going to add some config data, which I already have here, to configure the Geneva framework to consume tokens submitted by CardSpace. Included in this config is some simple identifying information about the application. It includes the realm from which tokens should be addressed to this application. It includes issuers that this application will trust to issue claims on behalf of a user. It includes a certificate to which this application will expect tokens to be encrypted to when it receives them, so that the Geneva framework can unencrypt the token on the application's behalf. So once we've done that, we need to create a login page for this application. I already have a template login application set up right here. It's already sort of integrated in the Contoso Hybrid Applications meme. It's got the right branding and all that kind of stuff. All I need to do is drop in CardSpace. So I'm going to do that. Because I've installed the Geneva framework into the Visual Studio environment, I'm going to simply select from the toolbox the information card tool. I'm going to drop it on the page. And then I'm going to do some configuration to tell the card control exactly what the token requirements are for this application. I'm going to tell it I want a managed card. And I have to configure a few items about how to display the card control. I'm going to start by telling it that it doesn't need to show a button image because we're going to use a CardSpace Geneva thing called the card control, or card tile. I don't want to display the remember me. I'm going to turn that off. I'm going to ask it to please indeed do show the card tile. I have to tell it who the issuer is that I will trust to issue tokens for this application. And I have to tell CardSpace where to find policy that describes where that issuer, what kind of token requirements that issuer has. Finally, I'm going to give it a list of claims that the application wants to consume. Save that. Okay. So once I've done that, I go back to the Fabricam site. Fabricam user tries to access the site again. This time they're logged in, or this time they see the card tile. The card tile here, I've skipped a step in the demo, but the card tile here is trying to indicate to them that they've logged in before, which we clearly haven't. But they simply click on that card tile, they get the CardSpace experience, click on the card they want to use. In this case, we're going to use Windows Integrated Auth to authenticate the user. We always want to remember the user in the future. We hit OK. They get access. The application has their name and information so it can customize the page for this particular user, including this particular user's privileges. So CardSpace with the Geneva framework has made this relatively simple to integrate CardSpace into an application in a seamless manner. So how did it do that? So when we added the CardSpace control into the ASP.NET web page, what it did in the end was when we rendered the page, it rendered this object tag control that invoked CardSpace when the user hit this page. The object tag control basically just offers to CardSpace the list of token requirements that the application needs in order to authenticate that user. It contains the issuer that we typed into the control. It contains the issuer's policy and the list of claims. And then invoking this particular object tag invokes CardSpace, which returns a token as a result, which gets form posted back to the ASP.NET page, at which point the Geneva framework shreds the token, validates that the token came from a trusted issuer, and validates that the right claims were passed in, substitutes that token for a cookie, and then from then on that application gets a cookie that has the claims in it. And it doesn't have to worry about where that came from or how it happened. Geneva just takes care of that for it. And it can just simply consume the claims that it asked for using the page properties of the user identity. So let's talk a little bit about the components that make up the CardSpace Geneva architecture. As I said earlier, we rewrote Geneva CardSpace from the ground up in native code. In order to do that, we had to find a new SOAP stack. When we wrote CardSpace v1, it was based on WCF. WCF is obviously managed. In order to rewrite in native code, we needed to start over. In Win 7, there's a new native SOAP stack called Sapphire, which we base CardSpace Geneva on. On top of that, we layer some simple WS Trust and MEX client code to do SOAP interactions with those particular protocol elements. The Federation Manager handles the majority of the policy retrieval and token exchange that I put in the earlier slides. And the Identity Manager is really the heart of the CardSpace service. The Identity Manager is what manages the user's relationships with different identity providers. It manages the store of cards that they have. It manages filtering and applying the intersection of claims between policies that are received from applications and the set of cards that the user has. It manages protecting that store using system credentials so that rogue applications cannot get at those cards. And it manages supplying credentials to the identity provider's STS and retrieving the token full of claims on the user's behalf that the user can then use to authenticate to applications. Native applications can consume the CardSpace service by writing to the native client API, which primarily consists of a single get token API, in which it looks much like that object tag control I showed earlier. It receives a set of policy, and when invoked, takes the policy, chases down more policy, and retrieves tokens, and returns them to the calling application. For a managed application, we don't have it in the beta yet, but we will include a managed adapter layer that would integrate us with WCF in the same way that we were in CardSpace v1. For web applications, it's the same kind of idea, except that we have an object tag extension that adapts the native API to a web page, to being invoked by the web page. But it takes the same kind of input parameters in terms of policy and claims, and returns the same kind of output, a token that can be used to authenticate a user to a particular application. It includes also an extension for the card tile control that allows display of the card that the user has used to log into this particular application in the past, so that they get a certain amount of context that explains what they're doing at this application, that they've been here before, and so forth. Both of these pass into the system can also invoke the credential provider interface, where we've integrated the user experience into the Windows CredUI system, as opposed to a totally and wholly different system like we did in v1, where we had our own experience. In CardSpace Geneva, we rely on basic Windows UI for collecting credentials and doing identity selection. It's just CredUI, and we're a credential provider within CredUI. And the native client API simply interacts with that, which then makes calls back into the client's identity manager in order to query for the right cards to display to the user, in order to give them access to those cards and let them choose the right ones depending on the context. And finally, there's a control panel applet that allows the user to manage the cards in their system, delete them, see the history of where they've used them, that kind of thing. So why is CardSpace interesting to an application? It solves three problems that are hard to solve in other ways. Those are home realm discovery, selection of personas in a single identity, and finally credential agility. So within the federated identity group, we refer to the home realm discovery problem. When we do, we're referring to the particular problem where we've got a federated application here who lives in a world where they trust a certain set of STSs to issue claims on the issuer's behalfs. We've got an app user who has a set of identities and identity providers that they're associated with. Somebody needs to figure out for the user which of these, where the overlap is between these two sets of STSs and which identities the user can use to log in to the application they're interested in logging into. In this case, it's CardSpace. CardSpace does a query against the federated app in order to find the policy, and using the policy, the list of cards that the user has, they can determine a set of cards that the user has that might actually be able to meet the policy the federated app has as advertised. The application doesn't have to take care of this problem. CardSpace does it for them. The user then can apply some extra context that they have in terms of what context or what application they are accessing in order to choose the right card and choose the exact STS needed to provide the right identity. There are other ways of handling this problem, and in previous talks you may have seen Federation Passive used in order to accomplish this. But the user experience might not be as nice in some cases. They might involve a drop-down list that the user has to select in order to tell the federated app what realm that they're in order to tell the federated app where to go get a token for this particular user. And that's not necessarily the best user experience in all situations, and further might result in your federated app having to share information about your federated partners that you may not be willing to share with anybody who's hitting that app. With CardSpace, you can simply advertise some more generic policy, allow CardSpace combined with the user's own context and their set of identities they own to combine those things and allow the user to select from among the realms that they're a member of in order to get logged into that particular site. Another way CardSpace is interesting is in respect to persona selection. In this particular slide, we've got a user who may have two different personas backed by the same identity. They have an admin persona and a regular user persona at this particular place. So when they hit their claims-aware app that allows them to log in as either an admin or a regular user, they get a set of policy that identifies this particular identity provider. It turns out they have two different cards for this particular identity provider, in which case they can select between the two roles that they want to play at this particular application. They select one of those, and as I said earlier, when CardSpace goes to contact the identity server in this case, it also provides the card ID of the card that was selected by the user. And this allows the identity server to select or to make choices about the kind of token that it emits on behalf of this user based on the particular card that was selected. In this case, the user selected the admin card, and that sent the admin card's ID to the identity server. So the identity server is going to choose the admin claim to include in the token that gets passed back to the claims-aware app. And as a result, the claims-aware app grants the user admin access as opposed to user access. Based on the same identity that they had at the same realm, the user was able to make a choice about what persona they wanted to use at this particular application. Finally, and my own personal favorite benefit of CardSpace is about credential agility. So today when you write an application, you generally have to write some UI for collecting credentials. And generally that UI is credential specific. If you're going to collect username password, you have to write some UI that collects username password. If you're going to do cert selection or something like that, you either have to rely on Windows cert selection UI, which I don't know, it's not my favorite UI, and or do something else more custom. And if you change between different credential types, you're going to have to change your UI, and you might also have to change the back-end authentication code in your application that actually validates the credentials that the user has sent to the application. With the claims-based access model, and with CardSpace in particular, your application can forget about those things. CardSpace handles credential collection, and it does so in a consistent way that users can get used to. And it does so regardless of, and your application doesn't have to be concerned with changing code in order to change the credential type. The CardSpace simply interprets the card and gets a key out of that associates it with a particular type of credential and presents the appropriate UI that's baked into CardSpace for collecting that particular type of credential. And the app can simply choose the credential type based on business or security needs without having to change its own code. And in addition, if you've offloaded to a relying party STS, the application doesn't have to worry about authenticating the credential as well. That can be handled by a Geneva STS. And as a result, applications can work in a world where credential types are changing according to business and security needs without having to change the code or the UI associated with that particular application. So that's CardSpace Geneva as it exists in the beta today, primarily. Let's talk a little bit about where we're going in the future with CardSpace Geneva, what you'll see potentially in the next beta and in RTM timeframe. So one of the things we're looking at, and we've prototyped a little bit, is while we're really excited about a brand new world where apps are claims aware and consume claims and tokens from issuers based on the Geneva framework or general purpose claims-based concepts. There's a lot of existing apps out there that don't yet participate in this world, but we would like to somehow integrate into this world. And so we've been working on ways of making that possible, particularly by providing ways of translating claims that come from tokens into Windows-based tokens that those applications can natively accept. Some of this was done in ADFS v1. We're looking at ways of doing it in a more generic fashion that doesn't rely on federation passive. So to dig in a little bit deeper, what we've actually prototyped is a SharePoint scenario, for instance. So we've prototyped having a SharePoint server running SharePoint Services 3.0. It's not claims aware. We have a regular Internet Explorer user accesses the SharePoint server. The way it's set up to begin with is using Windows integrated auth. As a result, Internet Explorer collects credentials from the basic Windows authentication service, LSASS, passes those over the HTTP channel. They go to SharePoint. SharePoint relies on its server's LSASS process to authenticate those credentials, and you get into the SharePoint site. The Windows authentication service has an extensibility point known as a security service provider, or an SSP. We've prototyped adding one of these. We call it the Federation SSP. That allows us to connect out to the CardSpace service, so that when, unbeknownst to Internet Explorer, when it calls out to the LSASS security service, we can vector a call out to the CardSpace service in order to collect a token on the user behalf to show UI and go find the right token that can get them logged into this particular SharePoint server. And in a similar fashion, on the server side, we introduce a Federation SSP on the server side as well. And in addition, we introduce a system service that translates claims-based tokens into native Windows tokens backed by a native Windows account over on that side that the SharePoint server can consume. So the SharePoint server collects its credentials in the same fashion it would over a Windows integrated auth channel, presents them to the security service, which vectors it over to the translating service, and gets back a regular Windows account. And neither Internet Explorer or the SharePoint server had to be configured any differently than normal, or is aware that they're participating in a federation scenario whatsoever. And it allows non-domain, non-forest users to access the SharePoint server using CardSpace. In addition, in the last year or so, Microsoft has acquired the rights to uProve cryptography technology. uProve cryptographic technology is interesting in cases where privacy is of the utmost. So in conventional cryptography, when an issuer issues a token, say that says, I'm over 21, or issues a birth date claim or something like that, the issuer can record that it issued this token. It can even record the actual token itself. And when the user goes and presents the token to a particular relying party, there's nothing that prevents the relying party from taking that token back to the issuer and saying, hey, by the way, I got this token from somebody. Can you tell me more about this person? And wouldn't you like to know where they took the token? And in other words, colluding with the issuer in order to find out more about the user and track their whereabouts. With uProve technology, that's no longer possible. The issuer issues a token to the user. The user applies some uProve cryptographic operations to it when they submit it to the relying party that they're trying to go to. And the transformation is done to that token, allow the user to prove claims about themselves to that particular relying party, such as their birth date or whatever else is interesting there, in a way that doesn't allow the relying party to take that token back to the issuer and correlate it with anything the issuer has handed out. There's no way for the relying party to match the two up, and therefore the user's privacy is protected. In addition to that, there are ways using this cryptography to determine derived claims. So the user can get a token from an issuer that says what their birth date is, for instance, or their name. But they can go to a relying party and prove that that their birth date is less than or greater than a certain date without revealing the actual birth date to the actual relying party. They can prove, in addition, things like that their name is not on say, a deny list without actually revealing their name to the relying party. It's as if you could take your passport, wave it over the list, and the relying party would simply believe that your name was not on the list without actually looking at the passport itself. Don't ask me how that works. There are smart people that know a lot more about me, a lot more than me about that. In addition, in V1, we did not handle roaming in a particularly smooth way. In V1, users were required to export cards into an exported card file format, and then we basically said, hands off, it's up to you to figure out how to get them where you want them to go, and then you have to import them. By the time we ship CardSpace Geneva, we will have made a considerably smoother experience, roaming experience. In particular, we want to be able to place a store on a device or in the cloud someplace and simply connect to it as opposed to export and import. And so we have some wireframe thoughts about what that's going to look like. It will be integrated, we hope, into the Cred UI experience that you saw earlier. There'll be an extra tile in there perhaps that says, would you like to find some other cards someplace? You click on that experience or on that tile, you get to authenticate to that particular location. We hope to give some hints and help that allow you to find that location easier. So if you've inserted a dongle into your machine, maybe it shows up automatically here. If you are using a well-known cloud location to store your cards, maybe it shows up pre-populated here and you simply select it. You authenticate to that store, and your cards simply show up in the list from here on out till you log out of that particular store or something like that. And you don't have to worry about this import, export. Your cards remain where you stored them. They don't necessarily get downloaded to this particular machine and left here if you leave the machine. And so roaming is a considerably smoother experience for users. So other future directions that we're talking about doing. So the private desktop was brought up earlier. Let's dig into that for a sec. So in V1, like I said, we optimized for the user who wanted to savor the authentication experience. And in addition, we optimized for security. Whenever you're making a security product, there's always trade-offs between security and usability. And in V1, whenever there was such a trade-off to be made, we chose security over usability. And it shows to a certain extent in the V1 UI. In CardSpace Geneva, what we want to do, instead of making those decisions for application writers, for users, we want to put some of that decision-making, the trade-off decision-making ability back into the hands of the people deploying CardSpace and the application writers. So what you'll see in CardSpace Geneva Beta 1 is not that choice, actually. There is some support for the Windows Secure Desktop, very primitive support for the Windows Secure Desktop in CardSpace Geneva Beta 1. What we want to do is make it possible to do things like perhaps mark a card as something that should only show up on a secure desktop, or have application policy be able to indicate that they should only be able to select cards if they're selecting them from the secure desktop. But the overall point is that instead of CardSpace making the decisions about these trade-offs, that there's a little bit more flexibility, and application deployers, writers, and users can make some of their own choices about the trade-off between security and usability. Other places we're going, we want to focus even more on making sure that install is quick, smooth, and gets out of the way. In V1, we were a part of .NET, and there was no way to get us outside of .NET. You had to download the entire .NET framework in order to get us onto a machine. In CardSpace Geneva, we're striving to be a separate download. We want to have a download and an install experience that's at least as smooth and quick as, say, a Silverlight download and install experience. So it's easy to get and deploy CardSpace on client machines without interrupting the flow and again, without having the user savor the experience. In addition, we're looking at things like admin policy for card use. So today, the user's in utter control about when to use an identity. Whenever you want to use CardSpace, the user's shown the cards that they want to select, even if there's only one, and even if only one ever makes sense. There are cases where, as an organization, maybe you have outsourced your email or something like that. And it's to somebody who consumes identity through the federated client token-based access model. And you don't want the user to necessarily see the seam between your organization and your outsourced service. And so it might be nice if you could provision for your users a card and then add some policy that said, use this card automatically and silently whenever the user logs into the email service that we've provisioned for them. And so in that way, the user can get single sign-on, erase the seams between federated services, and the user doesn't have to be aware that there is a seam there. They simply get the benefit of the claims-based access model without even knowing it. And lastly, we're looking at some richer policy alternatives. One of the oft asked for things in CardSpace is the ability to specify multiple alternative issuers so that we can give a more focused list of cards to users. In certain cases right now, what you get is a list that, or an application can specify a specific issuer or basically a wildcard that says any issuer with filtering done by the list of claims to narrow the list to one degree or another. We would like to be able to make that a little bit richer so that the filtering can be richer and more specific to the application at hand. So that's the CardSpace Geneva talk. The CardSpace, the Geneva system, as you may have seen in other talks, we have a beta 1 out right now. You can go to Microsoft.com/Geneva and download the bits, try it out with the rest of the system. There'll be a second beta in the first half of 2009, and we plan to RTM in the second half of 2009. In addition, all of the Geneva components are Windows components. CardSpace is still nominally associated with .NET. But the point here is that if you've paid for Windows, you get the Geneva components along with that. For the beta, we're going to support Win2K8, Windows Server 2008, and Vista. By RTM, we may well have added more platforms to that. We're still figuring out what our plans are along those lines. You won't be seeing us in the lounge of the pavilion because this is your last talk. If you've missed any of these other great talks on the Geneva system or the rest of the identity and services system, of course, they're available online. And please fill out your evals. Thank you.